we're going to do examples of how to calculate formal charges in a compound given the Lewis structure. And we're going to be using that a lot when we do resonance. So let's remember how we do formal charges. And in formal charges, we're going to do some bookkeeping of electrons. So the main thing that we need to remember here is the number of valence electrons of an atom. And for that, I'm just going to do, say, our mini periodic table that we use in organic chemistry. So let's say I have here hydrogen, and then we're going to go lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and that's neon, helium over here. So in the organic periodic table, we're going to be working with these elements in the second period. In some of the halides here, we also have sulfur right below oxygen, and we maybe have phosphorus. So right there is, for the most part, we're going to be using, say, this part of the periodic table. And what is important here, again, valence electrons when we're going to assign formal charges. So in group 1, we have 1 valence electrons, 2, 3, 4, 5, 6, 7. And that here the octet is complete, 8 electrons around. So let's do one structure, and we're going to be applying that. So first thing, let's say that I have aluminum here. And well, aluminum I don't have there. But I'm going to pick another similar example. Let's say this, I'm going to leave that for a moment and do, say, borane. That's the Lewis structure of borane. Boron has 3 valence electrons, and so when you do the Lewis, when you do the counting for the Lewis, you will have 3 and 3 electrons of each of the hydrogens. So total electrons, you have 3 from the boron, right here, 3 valence electrons, and 1, 2, 3 from each of the hydrogens, so you have a total of 6. And that's your correct Lewis structure, 2, 4, 6. Now when we go to formal charges, we're going to say formal charge of boron right there. So the number of valence electrons is 3 minus, then we're going to look at the electrons in bonds. So 2, 4, 6 divided by 2. So in here what we do is all of the electrons in bonds are going to be considered, say, split equally between the 2 atoms. So that's why we divide by 2. And the other thing that we add here is electrons that are not shared. So electrons in lone pairs, but we don't have any. So formal charge of boron here is 0. Now, if we had, say, this compound, now I have boron with 4 bonds. We're going to do the same strategy here. So formal charge here, and let's do another color. This one, again, formal charge of boron. What we need to know, first step was number of valence electrons. So boron is here, so it is 3, same with it before. Now, how many bonds do we have here? We have 4. Electrons in bonds are 2, 4, 6, 8. That is divided by 2. Again, we consider those electrons in bonds equally split between the 2 atoms. That's why we divide by 2. And we don't have lone pairs, so that will be 0. And that here is 3 minus 4. So the formal charge of boron here is negative 1. Similar to that is this compound. Aluminum also has 3 valence electrons. So let's do our bookkeeping of electrons here. So similar to boron, I'm going to do formal charge of, what happened? Okay. Okay, so let's do the formal charge of aluminum in this compound here. So formal charge of aluminum will be the number of valence electron is 3. And now we're going to go count 2, 4, 6, and 8 divided by 2. And I don't have lone pairs, so that is 0. So again, here, the formal charge is -1 for aluminum. We're going to do, let's do one more about using formal charges here. So I'm going to erase one of these. But I'm going to keep my, say, periodic table so that we can keep track of the number of valence electrons. Now let's do this compound here. And here, let's do the formal charge of oxygen. And I check out how many valence electrons. So I am here, 1, 2, 3, 4, 5, 6. It is in group 6, so 6 valence electrons. So I'm going to say formal charge of the oxygen is now 6 valence electrons minus. And then I'm going to count the electrons in bonds, so 2, 4, and 6 divided by 2. And then electrons in lone pairs, so not share. 1, 2, right? So what we have here is that this is 3 and 2 is 5. So formal charge net is +1. That equals +1. So again, what was the most important concept here when we're doing formal charges is, first you need to know how many valence electrons do you have. And then we are going to count electrons in bonds, and those are shared. Those are the ones that you divide by 2. And then we count the electrons that are not shared, so electrons in lone pairs. So let's write just, say, a general formula for what we just did. Applying that, and that you would use in any compound to do your formal charge. So say that formal charge of an atom X. So here you go. Number of valence electrons minus. And here you will count the electrons in bonds and divided by 2. And then you add the electrons in lone pairs. So that's exactly what we did. So in the case of oxygen, this number was 6. And then we counted bonds, so 2, 4, 6 electrons divided by 2. That was 3. And then we have 2 electrons in the lone pairs. So that will be the strategy that we need to use when calculating formal charges in a compound.